Yeah, I just started the recording. See, today we'll quickly see what are the different components required to create a VPC from Terraform and some different blocks that I'll explain. Apart from that, we also have some scripts written here. Get IP.sh, direct login.sh, sh login.sh, right? All these files are kind of a simple shell scripts that will do some magic for us. Basically, you don't have to get the IP address going to the console and log into the EC2 instance using SSH. We can do it by by accessing only through the git bash. The idea behind doing this stuff is you have to be very efficient in your work, and as a DevOps engineer, you are supposed to do everything from command line. Very little thing you have to do it from the console. So once you become efficient this way, right? I mean, you will be able to improvise yourself on a daily basis. Um, okay. For now, you can just have a look at the get ip.sh cat get ip.sh. Yeah. So we are firing a command AWS EC to describe instances and then using some filter. I mean, all of these commands may be very new to you, and then it'll not be that easy to understand. But if I explain you little things, then you'll be able to catch it up, but you will not be able to write it down immediately. So there are four commands for any resource. If you highlight EC2, right? AWS EC2. AWS is the cloud that we are trying to use, right? We are using AWS CLI. Whereas EC2 is a service or one of the managed service which is provided by AWS. Similarly, S3, VPC, you have so many different services provided by AWS. The second one is the service name. The third one is third column. Just a second. The third one is all about whether you want to create instances, whether you want to create S3 bucket, whether you want to modify the existing bucket, whether you want to delete something, whether you want to list something like that. So there are only uh, at a high level, there are only read and write. Read means you can do just view the content, view the resource name, other details like that will be describe, list, uh, show, get. So different operations that you can think about. That will be mostly connected to your English only. See, if you say get, it is not read, it is not write, right? If you say show, it is not write. If you say describe, if you say list, that is also a read operation. Whereas if you think about write operations like modify, delete, update, change, whatever you do, that is a write operation. Create is also one of the write operation. So all of your operations fall into one of these categories only. So now we are doing describe instances means it's a read operation. We are trying to see the number of instances running. In that we are having filters. If we just highlight filters, uh, yeah, after that you have a name. You are saying instance state name. Instance state, what is the instance state? Value should be running. If the instance is running, then query for the reservations. I mean, whatever that output it has a reservation as a key. In that reservation key, we are searching for all the parameters. That is why we put star inside. You can just go to the query and reservations. Yeah, and then we are saying again all the instances, and then looking for only the public IP address in the end. So if you probably remove the query, okay, you can just run the command, just copy paste the command and
Yeah,
just
so Samesh,
right click. The complete line. The complete line. Yeah.
Till
Copy.
here.
Yeah. And enter. You're not going to get anything because the instances are not running. Uh,
Yes.
Similarly, if you do a cat a direct login.sh,
Cat.
direct direct login, yeah, tab, yes, good. You started using uh, tab
Very
efficiently.
easy, sir, to use that.
Sorry.
It is very comfortable when we use tab, or else we need to type the entire keyword and then press enter.
Correct. And moreover, you will end up maybe making some mistakes by typing, right?
Correct.
Whereas
Some
if you use
space
tab,
or part. So,
correct. If you use tab, it is going to give you the actual name that is already there in the system. Maybe even if
yeah.
you make mistake in while creating the file name or folder name also, you will get to know, okay, there is a problem. There is a mistake that you made it. Now here we are writing a shell script file. The first line is a shebang line with a hash, exclamation mark, and bin sh. That is telling what kind of script that we have written. Because from shell you can write any scripts. Why? You can write any script like Python script, shell script, uh, anything like Golang, anything you can write it and execute from shell. That is the beauty of shell. I mean, git bash or shell. Next three lines, I'm trying to assign variable values. Key name ec2-vpc.pem. That is something which is currently being created by our script. I mean, our Terraform script. And user is by default it is ec2-user because we are using Amazon Amazon Linux machine. The IP address will be retrieved from the uh, /get ip.sh, the the script that you executed, right? That you did a cat, yeah, cat a little above, no, just above, just even little bit more, yeah, there. That particular script that we are calling from this particular line and then getting the IP address so that the IP address is known to us from the script. Then finally, end of the line, end of the file, we are running ssh-i key underscore file and then user at IP address. Wherever you see dollar, that means we are calling the actual variable value and replacing the variable value over there. It is similar to Python where you don't use dollar symbol, but we use just a variable name to get the variable value. Here we just use extra dollar for that because that's the way shell works, shell scripting works. Now what you can do is you can just cat ss underscore login.sh. Can you do a cat ssh underscore login.sh? Okay. This file again contains three parameters, but it is more or less the same, but it will be little uh, uh, little advanced, I would say, but it is a very basic one. If you look at the dollar hash, that is trying to compare how many parameters that you are passing. Uh, yeah, if dollar hash not equal to 3, if you're not passing 3 parameters, then it will come out of this particular script because it expects key file. If you go down a little, you have a key file equals $1, user equal to $2, IP address equal to $3. Like that, we are assigning values from the arguments that we pass. So here, when you run the sh underscore login.sh, you have to pass key file, username, and IP address, similar to how you do it from the command line. It is more or less the same as the other file. You can just do a control L. I mean, once you understand what we have done is clear. Control L. Yeah, do a ls now. Control L is to clear.
Clear, yes.
Now you can open variables.tf. Yeah. So here we are trying to define all the values in the variables.tf file, uh, starting from VPC CIDR subnet. Two subnets we are going to create. Subnet, you are already aware that if you want to split the existing network into smaller pieces, then we have to create a subnet
Yes.
and start using the uh, subnets for creating your EC2 instances, creating your resources. You have a Ubuntu AMI ID that when we use Ubuntu AMI ID, we'll use that particular variable. Otherwise, we'll use AMI underscore ID.
Ubuntu, okay. If we use the Ubuntu system, then we have to use this, is it?
Yeah, that will be the variable that we'll be referring to. Otherwise, we'll be just referring to AMI underscore ID. T2.micro is a default instance type that we are using because we don't want to get charged for anything extra while we are creating and playing with AWS resources. If you slowly come down, you have a tag that will be added for all the resources, especially when we are creating resources through Terraform. We should have more tags so that a person who's looking at the resource can understand this is coming from Terraform, this is created by Terraform. What is this environment? Is it a production test or a stage? Depending on for whom this environment is available for testing. See,
Will it automatically tag or do we need to do it manually?
we tag every resource that is created.
Okay.
Wherever we say var.tags, there you can see the tags added. Now you can close this file. You can open main.tf. See, the agenda behind Terraform is, see, you should understand the blocks and you should be able to write the blocks whenever it is required. For that, you have to have a proper understanding how to write a variables.tf file, how to write a main.tf file, how to write a resource.
Yes.
Okay, you can open main.tf. So every block has minimum two columns. First column is the either the provider, a resource, a data, or output. So it should be one of the parameter. It could be mostly it could be resource and provider. Whenever it is required, it will be output, data. Uh, so data and all we are not using much. We are using only resource and provider. So resource block is followed by the resource name, the fixed resource name of the particular cloud, AWS underscore key pair, AWS underscore VPC, AWS underscore subnet. Hi Sanket.
Sir, good morning.
Yeah, good morning. So I'm trying to explain each block in Terraform, and we also started with explaining the shell scripts that are available in this particular GitLab repository. Okay, so you can probably go back and look at the recording because we started recording from the initial minute when I started explaining things. So you can look at the recorded session, and we can now quickly go with the flow. So,
Got it.
yes, Sanket.
Got it, sir. Yeah.
Sure. Now, if you look at it, creating a VPC, can you put colon set nu colon?
Where, sir? Where?
Yeah, inside the git bash, you can put colon, similar to how you do it, right? I mean, for saving colon, just simply type colon. Yeah,
Yeah.
space set nu space nu space. Yeah, it will set the numbers for each line so that it becomes easy for you to understand. And line by line we can go enter. Yeah, okay.
Oh,
So it becomes handy for people to just look at the uh, text file with the numbers, line number. So if you go a little up, maybe line number 26, 27. So line number 23, 24, 25, 26, right? It is all talking about creating a VPC. For creating a VPC, you require a CIDR block. CIDR block is nothing but a network IP address block that says how many IP addresses can be assigned to that particular CIDR block.
okay.
And for that, you need to have a little bit of understanding of networking. Basically, if I say /24, how many IP addresses can be assigned for that particular network? If I say /16, how many IP addresses can be uh, reserved for that particular block, particular CIDR range? So you can probably go to now you can just go to your browser and then search for CIDR block calculator, CIDR calculator, CIDR calculator. Yeah, go to one of the link. Yeah, you can simply search for 10.0.0.0. On the right hand side, you can select /16. So that itself will say how many IP addresses are available for this particular range. It is all about, say, somebody says 1 to 100, right? You
Mm-hmm.
don't have
Yeah.
to write 1 to 100. Say, for example, in the for loop, right? A range of 1, 100. That means you are getting values from 1 to 100, 1 to 99. Like that, you can also have any range given by CIDR. I mean, given by IP address. So you for this 2 to the power 16 minus 1 is a total IP address range that can be assigned to this particular network. Or you can say simply 2 to the power 16.
That is 65,536.
Similarly, you can also search for /24 and /32. You will understand, I mean, slowly what it says. /32 means only that particular IP address can be used. So it cannot be used in the CIDR, especially in the VPC. VPC, you are supposed to use at least /24, /28, depending on how many IP addresses that you are going to create in that particular network block. So based on that, you have to calculate. I mean, you have a calculator for everything, but you should have some common sense before you create any resource, before you create VPC.
Okay.
Okay, any questions on this?
The total IPs in this range is 1, right?
Yeah, correct.
So if we give 16, there are 65,000, and if we give 32, there's only 1.
Yeah.
Okay, as the number reduces, the IPs increase.
Yeah, it is basically 2 to the power 32 minus the number that you put. Say, for example, if you want to write it down on maybe simply on a paint or maybe some other document, you can open it. Draw.io or something. I can tell. Yeah. Simply any tool that you can, paint is okay. You simply write a 2 to the power 32, like numbers. I mean, you have to probably use a pen and then start writing 2 inside. Yeah. If it is /16, it is 2 to the power 32 minus 16. 2 to the power 32 is the total range for the IPv4 address. See, because we are using IPv4, right? Yeah, 2 to the power 32 minus 16. That is that equals 2 to the power 16, right?
Yeah, obviously 32 minus 16. Yes.
Yeah. So 2 to the power 16 is the total number of IP addresses that you get it. For example, if you put 2 to the power /28 /28, yeah, you can put /28 and then you can start writing some 10 dot. Yeah, that is also more than enough. So you put a equal symbol or right arrow and then start writing. Yeah, that is 2 to the power 32 minus 28. That is 2 to the power 4.
Oh, okay.
So it becomes 2 to the power 4 means it is 16. 16 is the total number of IP addresses available for that particular network or particular subnet.
We're doing with, say, 10. Whatever it is, we are subtracting it with 32.
Yeah.
Got it.
So like that, the calculation goes. And especially when you create a subnet, it should be the subset of your VPC CIDR. That means the number should be more than whatever you have defined in the VPC. If it is /16, your subnet should be at least /18, /20, /24, like that. It should never be a lesser number than your VPC. For example, if I give you 10 pencils or 10 boxes, right? From there, if you want to divide, how many you will take it, how many you will give to Sanket? Maybe half of, or maybe you will take 2, you will give 2, right? You cannot give 12 to Sanket since I gave only 10. So it should always be lesser number than the VPC. If you are dividing from the top, if you are dividing the original number. Hope I'm making it clear.
Yes.
Okay. So basically subnetting is all about from the available list of IP addresses, you are trying to divide them into smaller pieces. Subnetting also comes with the CIDR, like VPC. VPC at the high level, subnet is at the low level. So you'll slowly see and try to understand how subnetting works. But I would advise you to go through more stuff on the CIDR and subnet, so that you have a clear understanding how the subnetting works. Now you can go to main.tf file. You can probably close this file, open variables.tf, because in order to understand how exactly we defined in the variables.tf. You can slowly come down. Okay, you have to go up. You are at the bottom of the file. Yeah, keep going up until you see VPC. Yeah, you can probably stop it here. So line number 5 is the VPC CIDR, and it can take up to 16,000 IP addresses, right? Roughly. And if you look at line number 9 and line number 13, it's all about public subnet CIDR. How we are just splitting the subnet. /24 means 2 to the power 8. 2 to the power 8 means probably 256 IP addresses. Yeah, 16 into 16 will be 256. 256 IP addresses we are giving to one particular subnet. So at any time, you cannot go beyond 256 machines in that particular subnet. It will be the range will be out of your available subnet range. That's what it means. The maximum number of instances that you can create in that particular subnet is 2 to the power 8 is 256 minus some 1 or 2 IP addresses which are assigned for the networking. So you have to read a little bit more about what is subnetting, what is networking, some basics of networking. So we are leaving the access key and secret key. I'm just moving on to the next stuff. On line number 17 and 21, default, it becomes null, right? We don't define any variable value for this because we already configured AWS CLI that has that variable access key and secret key assigned. That is why we don't have to really assign any value to this parameters. We'll look into this one a little later, but try to understand we don't need to define any variable value for this because we have already configured AWS CLI using AWS configure command.
Okay.
You can now close this. I mean, you have a couple of other variables like availability zone. That is to make your resource highly available, and especially it'll be good when you are creating a cluster, not just like single EC2 machine.
Variable AMI ID is also there, right? Variable
AMI ID is also there.
AMI.
So we define all the variables that are required to create other resources. We are not hard coding any of the values in the main.tf. We are only using that key file and things like that. Yeah, you can close this file. You can open a main.tf file once again. Okay, you can go. You can put a set any. You can put colon. Sorry, escape, escape colon up arrow. One more up arrow. Yeah. You don't need to necessarily type also every time, especially if it is if it is written something after colon, you have a history command that will work. Use up arrow like that. Okay. Now, access key, secret key, we are not defining anything. If you look at line number 7 to 9, right, it is all about running sh keygen -t rsa. That particular command, we are running it from Terraform to create the private key. That we will be running it on the AWS systems in our account. So 7 to 9 will be executed on the remote machine to create the private key. But private key, and then the line number 13 to 15, it is about creating the key pair. So creating a private key and creating a key pair and copying the file into a local machine, all are should be in the same sequence, or maybe everything should be done in the same manner, because it is a single command when you run from when you run from git bash. But when you are running from Terraform, it is little complex. This block you can probably skip, but you try to understand how this is working. You're just running a sh keygen command from 7 to 10, and 13 to 15. You're just trying to make sure it is a key pair, public and private key both. You're just giving a key name. You're just making sure public key is saved at that particular location, like public key equals TLS underscore private key dot private key dot public key open SSH. I mean, using open SSH, you are trying to get the public key from the private key. So it is always associated with your private key, the public key. So we are generating the private key first. From there, you are generating the public key. If you look at the line number 15, right, it says TLS underscore private key, right? That is nothing but line number 7. You can see resource TLS underscore private key, right? And then private key is the name of the key file that we have given. If you look at line number 15, you can see that TLS underscore private key, that is actual private key that is created on AWS, and then the name of the private key is private key. So we can just say my private key something, so that it becomes easy for you to understand. You can change it to private key into my underscore, or maybe you can say Akshay underscore private key, so that it becomes quite clear. Line number 7 first. Line number 7.
This private key or the right side one?
This one, yes. Go to insert mode. No. The last column. Yeah. Insert mode and then say Akshay. No. Okay. You can say Akshay. Yeah. Simply say Akshay also. That is also fine. Akshay underscore key. Correct. Yeah. In order to at least understand private key, at least say P key. Yeah. Now just come down. On line number 15, wherever it was private underscore key. Yeah, no, not that. That is the actual resource name, TLS underscore private key. Yeah, this one you have to change. You put a P and then here you put Akshay. So not just this one, and then you have to also modify line number 21. Yeah, correct. Uh, Correct. Yeah, exactly.
And not this, right? This is the pen file.
I think that is not required.
Okay.
Let's see. I mean, let's run it because see, I'm also not doing it regularly. These kind of activities. No, that is fine. Escape. Colon WQ. Okay. Maybe you can open main.if once again. We'll try to complete all the explanation and then we'll go for. So we were into see the resource local file. You can go with colon up arrow. One more, yeah, right. So line number 19 to 21 is all about how to copy the private key to your local machine.
The
Okay, the file name, right, on line number 20, about your key underscore name dot mem. We are using key name as EC2-VPC. End of the line, we say key underscore name, right? The key underscore name is all about the name of the key. Key underscore pair, that is all about the resource name of the key pair. AWS key pair is the actual resource. Key underscore pair is the resource name, and then key name is the last one. That will be the file name. That means the name of the key name is EC2-VPC. That's how we define. If you look at the line number 14, right? The key name is where.key name. Where.key name is coming from your variables.tf, that is EC2-VPC.
okay, so this is a comment, right?
No, yeah, that is a comment. I mean, after the actual assignment, I'm just putting a comment to understand, to make people understand.
Okay, yeah.
Okay, you can slowly come down now. So line number 21 is all about talking. It's all about what is the content that public key will contain. Sorry, the private key will contain. TLS underscore private key dot action underscore private key dot private key underscore pem. That is the content your private key will contain. Now you can go down. So you see public subnet. Subnet requires VPC ID, CIDR block, availability zone, and line number 35, public IP on launch true. That is like how whether you're getting the public IP while creating an instance in that particular subnet. That is what it means. If you're creating private subnet, mostly you don't require a public IP because you are making it as a private. Here we are using the var.tags. The tags will be coming from the variables.tf file. Okay, we'll slowly go down. For both subnets, it is the same parameters.
One public.
On line number 47 and 48, we are creating uh, internet gateway and then attaching the internet gateway in line number 51, 52. Sorry, 51, 52 is creating a route table, and 55, 56 is attaching the internet gateway to the route table. So unless you attach the internet gateway to the route table, your network will be incomplete. In order to make the network complete, you have to create the internet gateway and attach it to the route table.
Okay. And what about NAT gateway.
NAT gateway is required only for private subnets. Private subnets to talk to the internet, we need NAT gateway. So we are not creating NAT gateway here. By next week, we'll create NAT gateway, and then we'll create a full-fledged VPC private subnet and instances in both the subnets.
Okay, so here we are using public, so no need of NAT.
It becomes public only when you attach internet gateway. If you attach NAT gateway, it becomes a private subnet. If you create a resource like NAT gateway, it becomes create a NAT gateway and attach a NAT gateway to the subnet, it becomes private subnet. So subnet will not become public or private just based on the name. So it is changing, it will be changed only based on the attachment of the NAT gateway or internet gateway.
Okay, got it.
Yeah. Just slowly come down. Yeah. You have a route table association for both subnets, like line number 60 to 67. You're associating a particular subnet. Sorry, you're associating the route table to the public subnet. Subnet ID you are getting it from the AWS underscore subnet dot public one dot ID. That is the resource that we created just above, and we are referring to that particular resource. .id means it will fetch the ID of that particular subnet and then associate the route table to that. On line number 67, you can see that route table ID equals AWS underscore route table dot public underscore route table dot ID. One route table that we are creating, and then we are putting them to two different subnets. So we don't require more internet gateways. We just need only one internet gateway. For example, at your home, how many Wi-Fi routers you buy?
One.
Yes, sir.
Only one.
Yeah. So how many Wi-Fi routers you will put it in your home? One, right?
One.
Yeah. Because see, no matter how many laptops or mobile phones you connect, even in big organizations, maybe they'll have multiple Wi-Fi routers, but in terms of like smaller offices, even for 100 people, they'll have only one router. So that is what I'm saying. So the internet gateway is a single internet gateway, and you are creating a route table. Route table means the rules. I mean how the internet connection will be routed. What are the different rules that a route table contains? That is what is route table rules that we are assigning to subnets to make it public. Line number 67 and 62. 67 and 62.
Okay.
Okay. Going down, we are creating the security groups. From line number 70, we are creating the security group and assigning the particular side this one from port to port protocol. Whatever you do it in the console, right? The same thing you are typing it here and then creating them. So this is all about. I mean, what I mean? Writing everything as a code instead of going in and creating everything in the console. You can just go down a little bit further down. You will see ingress and egress. So ingress, when I line number 84 to 86, right? From port and to port. That means from 80 to 80, any range is allowed. We are simply trying to save writing multiple blocks of ingress. We are just saying from port 80, end port 80, from 80 to 8080, all the ports are allowed to be accessed from outside world. That is what ingress, right? What is egress? It is outgoing traffic. So we don't usually restrict outgoing traffic. That's why we have -1 in the protocol, and from port and to port are 00. That means anything from the VPC can go outside. There is no restriction. Because if you want to look for some other data from the internet, you are allowed to go outside and then fetch the value and then get it. For example, installing some packages, pulling some information from other websites and then displaying it here. You are free to go to the internet and then fetch fetch the information and use it here. And the CIDR block is always for the outgoing traffic, it is 0000, which is line number 94. IPv6 CIDR block is not required, but we have just written down. IPv6 is not widely used, but we are just trying to put all the possible values here. Now, line number 102 to 109, right? It is very familiar one that you created for EC2 instance, like key name, security group, user data. User data is the only thing that is new for you now. That is all about installing some packages, configuring the EC2 instance with a predefined set of packages or softwares. That is basically calling a shell script, or maybe you could have used user data while creating the EC2 instance. I hope you would have got it from Prasad, sir.
Yes, we have seen, but we don't know how to write it. So
Yeah. Basically, shell script is all about writing the statements in a sequence and executing them by calling the script. That is very simple. You will slowly understand. Okay. So next piece of code, right? If you go down, you get AWS underscore AMI underscore Ubuntu underscore ID, line number 124. So we are trying to use Ubuntu AMI ID here. But as of now, I have commented it out because we don't want to create any other resource for now. No Ubuntu instance, only Amazon Linux instance that will be creating. Okay, you can close this file if you don't have any doubts. If you have any doubts, you can ask me.
131 lines of code.
Yeah. Yeah, do a ls. You can do a control R, Terraform, space init. Yeah. So I basically wanted you to run this particular command. Terraform init, validate, plan, apply, and destroy. Sorry, not destroy, apply. Yeah. You might say this. This change particularly. I'm doing it only today. That private key name, right? We'll see if there is a problem. We may have to fix it.
Okay.
If that is good, then we are in the right direction.
So if we give Terraform destroy, so will it also destroy the resources that we created? I mean, the changes that we made in Vim file, main.tf file.
Yes. Yeah, if you are making a change in the Terraform file, say you are removing a block of code, that will actually remove the resource that is already created, if it was already created. So it is going correct. See, if you see TLS underscore private key, Akshay underscore key, right? It is created, and then it is created the local private key also. So everything is fine.
Okay.
Uh, Sanket, if you want to run a Terraform init to understand whether it is creating all the resources, I think you have done it yesterday, right?
Yes, sir. We have done it yesterday and day of yesterday as well. It will work.
Oh,
And we had yesterday.
tough. Yeah, Sanket. Okay, and do one thing. No, don't do that. Do ALS. Do a dot slash direct login to SSH. Direct login SSH. Yeah. Enter. You will be automatically logged into the system. You don't have to remember the IP address. You don't have to go to the console, get the IP address. Yeah. This also can add strict checking also, but we'll do it later, not now. So now you logged into the EC2 instance without the need to go to the console, without the need to find out the IP address, without the need to type the key also. So you feel it is more easier than creating instance from console, right?
Yeah.
If you look at it right, in the long run, say for example you are creating multiple EC2 instances, multiple other resources on AWS, if you could do it just by writing a script, then that will save a lot of time for you, right? That is why infrastructure as code is in place for most of the organizations. Uh, it is very rarely, especially when they moved on to cloud, there are lot of positions open, a lot of engineers work on Terraform. Not just Terraform, you have to be aware of Terraform, you have to be aware of GitLab, you have to be aware of AWS resource, AWS console. At least AWS console, if the chance is there, you can work for GCP or Azure also. But in any case, Terraform and GitLab is not going to change. Only your cloud will change.
Mm, yes.
Okay, I guess I made it clear all the topics, especially with respect to VPC. I would, so you please ask anyone who is available in the class who is reaching out to you anytime. Just go listen to the today's recording so that it all clear.
Mhm.
You can also go to VPC and look at the VPC details. Right click and open in a new tab.
Oh
Okay,
yeah. Okay.
fine. That's fine. It is okay. It is okay. See, always have that habit so that you are able to refer it back. So you can see that a subnet is created. 10.0.0.0.16. Yeah. Now you can quickly go to your this one git bash and run Terraform destroy. You have to do a control D to come out because you are on the remote machine now. Do a control R dash dash destroy. Sorry, uh, destroy. Yeah. Okay, you get that right. Okay. It'll remove everything. Whatever it has created, it'll remove everything. You don't have to really just go and delete things one by one.
VPC, EC to everything, right?
Everything. Whatever it has created, it'll delete everything. You just go to the console, you just refresh, it'll be deleted. So it
Okay.
is waiting for the other resources to be deleted. VPC will be deleted in the last. If you go to right click and open EC2, right, you will see that instance is terminated almost. Click on search. Click on the search. The the next to the services. Yeah. Clear. Type EC2 and then right click and open in a new tab. Now you go to instances, so it becomes 0, right?
Yes.
There are no instances currently running. Even if you go to security groups, whatever security group it has created, it will delete it. Or whatever key pair it has created, it will delete it.
This is the default.
Yeah.
Okay, that's it. That's VPC.
You can go to VPC, refresh. Yeah, everything is deleted. So basically, that's how it works. You don't have to really worry about whether resources are created, resources are removed, resources are modified. So you just need to be very intelligent enough to write the scripts, run the scripts, make sure you understand what the plan is, what it is doing while doing apply, what it is doing while doing destroy. Destroy, we don't usually do it in the organization unless we are tearing down a particular environment or we are trying to recreate another region or other account. We don't do Terraform destroy. Okay, hope I made it clear. Any questions, anything? Feel free to call me, contact me.
Yes, sir. I got and I understood a bit of it today.
Yeah.
Just go through the recording to reinforce it.
Sure. Sanket, you have any questions?
As of now, no, sir.
Sure. Okay. You close the call, today's call. Thanks all. Thank you. Bye.
Thank you, sir. Yeah.
Thank you so much, sir. Happy weekend. Bye.
Happy weekend. Bye.